All right. Guys, so here's the deal. There's going to be two things that we are going to take a look at today. And then this is what your lab is actually going to be over. So the two things that we're going to take a look at today are speed and velocity. All right, speed and velocity. Now, speed is actually listed right here on how to calculate it. So speed is just distance divided by time. And honestly, you could probably figure that out, because if I asked you guys to tell me how speed is calculated, a lot of you guys might think miles per hour. Okay? That's probably the most common speed unit that you're used to, because that is how you tell the speed that a car is traveling. All right? Miles per hour. So miles would be a measure of distance, right? Hours would be a measure of time. So that's how we actually calculate speed. Now, the only difference between speed and velocity is this. Velocity includes a direction. Okay? So if I said that I was going 50 miles per hour, that would be a speed. If I said that I was going 50 miles per hour north, that would be a direction. Does that make sense? Okay, that's the only difference. So if we want to think about this, remember back when we talked about scalar quantities versus vector quantities? And vector, we said, was an arrow with direction and magnitude. All right? So velocity is a vector quantity because it includes direction and also magnitude. So it gives you how fast it's going. That's really your speed, but it also gives you the direction that it's actually traveling. So that's the difference between speed and velocity. So if you want to write on there what velocity is, okay, velocity is just speed with direction. Okay? Speed with direction. All right. Okay. Now, let's take a look at one of these examples. So, number one says that we have a football field that is 100 meters long. Okay? And if it takes a person 20 seconds to run its length, how fast, meaning what speed, were they running? All right, so think about this. Our speed, remember, is distance divided by time. Okay? All right, what is your distance in this case? Alex? 100 meters. And what is the time? How long does it take the person to run the distance? 20 seconds. All right? So, what is 100 divided by 20? That's going to be 5 meters per second. Five meters per second. Everybody understand how I got that? Anybody not understand how I got that? All right. So look at number 2. This says the pitcher's mound in baseball is 85 meters from the plate. seems a little far to me, but we'll go with it. All right, it's 85 meters from the plate, and it takes 4 seconds for a pitch to reach the plate. How fast is the pitch? Okay, again, how fast, that is our speed. So speed is distance divided by time, d over t. If the mound is 85 meters from the plate, and it takes 4 seconds, our distance is 85 meters, and the time is going to be 4 seconds. Okay, so 85 divided by 4. All right, somebody tell me, what's 85 divided by 4? What is it?
21.25.
21? Is that what you said?
Yeah, 21.25.
21, okay. 21.125.
Just 2.5.
0.25, there we go.
No. It's just, no, it's 21.25.
Yeah,
Okay.
21.25. There we go. Okay? So, that unit's going to be meters per second. Now, what would this be in terms of sig figs?
21 minutes. Wait, no, sorry. Wait.
0.25.
It'd just be 20. Because 4 seconds, that's 1 sig fig. So technically, we round that to 20 meters per second to be in line with sig figs. Did you get a packet yesterday? All right, we're on the first page. Now, number 3, we actually have to rearrange a little bit. This says if you drive 100 kilometers per hour for 6 hours, how far will you go? So how far, which variable are we solving for? Speed, distance, or time? Distance. So we need to rearrange to solve for distance in this case. So your normal equation is S equals D over T. We need to rearrange to solve for distance. So that means we need to move T to the other side of the equation. So to be able to do that, we're going to multiply both sides by T. That's going to cancel T over here. And that will give me distance equals speed times time. All right. Now, if distance equals speed times time, our speed is what? 100 kilometers per hour. And what is our time? 6 hours. All right. So in this case, hours are going to cancel out. And 6 times 100 will give you 600 kilometers. So if you drove 100 kilometers per hour for 6 hours, you would go 600 kilometers. All right, everybody with me on that? All right, skip number 4, jump down to number 5. Number 5 says, every summer I drive to Pennsylvania. I don't actually drive to Pennsylvania, but the person in this problem does. Every summer I drive to Pennsylvania, and it is 895 kilometers to get there. If I average 100 kilometers per hour, what is that? 100 kilometers per hour. Is that distance, speed, or time? That's the speed. How much time will I spend driving? So if we're trying to solve for time, let's go back to our equation from number 3. D, which is distance, equals speed times time. All right? So what we're going to end up with, to solve for time, we need to get speed over here. Well, if we want to move speed, if we're multiplying it right now, what do we need to do to speed? You always do the opposite of the operation that's being done to it. So if speed is being multiplied, what do we do to it? We divide it. So divide both sides by speed. So distance divided by speed. Okay, speed's going to cancel over here and leave you with time equals distance divided by speed. All right. And what it's going to look like is this. Distance is what? 895 kilometers. And what is the speed? 100 kilometers per hour. Okay? And if we divide those, 895 divided by 100, what's that going to give me? 8.95. And what's my unit? Hours. Because kilometers is going to cancel out. You'll be left with hours. So 8.95 hours is going to be my answer. Okay, is this making sense?
Did we round that up to 9 hours?
So according to sig figs, 100 has 1 sig fig, 895 has 3. So yes, you would round this up to 9 hours to be in line with sig figs. Number 3 is already good in terms of sig figs because 100 and 6 both have 1, and then 600 also has 1, so that one's fine. But yeah, number 5 you would round up to 9. And again, anytime you're showing sig figs, I would show both, like your original number and the number after it's rounded, just so it shows that you went through that process rather than just skipping straight to the number of sig figs. All right, does anybody have any questions? Okay. I'm going to give you about 10, maybe 15 minutes. I want you to do the rest of the problems that are here, which gives you 1, 2, 3, 4, 5. Okay? Going to number 9. All right?